Okay, guys, first go at this. Today I'm going to be teaching you how to solve quadratic equations by extracting roots, or square roots rather. And as always, we have a list of objectives here. And since I'm the only one filming today, I have to both focus and teach at the same time. I apologize for this not being on your PowerPoint slide, but it is in your notes. You can just refer to them. This will be in there. But first thing I wanted to talk to you about was to do this, and by the end of the day, you'll be able to solve quadratic equations by factoring, be able to apply them and extract square roots. You'll be able to solve quadratic equations by completing the square, and also find a quadratic equation given its solution. So we'll pretty much only focus on the first two for today. Second two will come next lesson, next class. So sorry if that's not all perfectly centered. But to do this, to solve quadratic equations by factoring, you need to understand that the definition where it says any equation can be put into the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a can equal 0. So if that happens, that's called a standard equation in a quadratic equation in standard form. Something very important to be able to solve for these things is to use something called the zero product property. Zero factor property to solve the equations by factoring. So the zero, and I call it the zero product property, I'm sorry. Definition-wise, though, in our notes, it's called the zero factor property of real numbers. Really, that relies on the fact that if a times b equals 0, that a equals 0 or b equals 0. And definition-wise, that might be kind of hard to understand, but I think if I show you a few things on the board, maybe it'll make things a little bit clearer. So if you think about it, 3 times 0 equals what? 0? Would you buy that? Or 0 times, I don't know, any other number, 3 or 4, that also has to equal 0. So that's really what the zero product property entails. It pretty much says that if A or B equals 0, for A times B to equal 0, then either A has to equal 0 or B has to equal 0. So one of those two, you can see, must be 0. 3 times something has to be 0 to equal 0. And likewise, the first term, or first number here in this product, times 4, if this is 0, 0 times 4 equals 0. One of these things has to be 0. That's all I'm trying to say, right? Maybe not so clearly, but something times something equals 0. One of those somethings has to equal 0. So the goal in all this is if you get this quadratic equation set equal to 0, and that's the big part, that's the important part. The question becomes, how can you use the zero product property to solve that equation? Well, to do this, we have to rely on something we've done in previous classes, is the factor it first into a product containing two factors. You guys remember how to factor this? Using the reverse FOIL process, or factoring, x times x, first terms have to multiply to this. And like we talked, we're now looking for two numbers that multiply to -6 that add to -5. Can you tell me what it is? Can you think about it? Well, 2 and 3 work. Would that work? 2 times 3 would give me 6, but a negative times a negative would make it positive. So remember, in our guessing and checking, you don't have to always use them. Main key is to try something to get started. So 2 and 3 do not work because they did not multiply to -6. How about -6 and 1? Would those two numbers work? And in this case, they do work. Negative 6 times 1, the last terms multiply to negative 6. And if you add the last terms, which is 1x, minus the 6x, that gives you a minus 5x. So that's just a little bit of a review. I know you guys are already good at this. But factoring it is the key part. Because now what happens is you have two factors where you can now apply the zero product rule. Now, make sure that you understand that the zero product rule can only be used when it's equal to 0. If something times something equals any other number, there's too many combinations. You cannot use the rule. And over the years, that's where people tend to make their mistakes. Once you're here, remember either the first term or the second term has to be 0. So you can actually physically write either x minus 6 equals 0 or x plus 1 has to equal 0. So one of those two things has to be true. When you solve for x, plus 6, and this one, minus 1, to find that x either has to equal 6 or x has to equal negative 1, one or the other will make that statement true. Now, it is important, as I step off camera here, and I'm sorry for the focusing factor, but as I step off here, that one or the other one can work, and you can always and will be asked to check your answer every time you do this, because it is possible that they both work, it is possible that only one works, and it's possible that both work. So if you go ahead and check this, for instance, check x equals 6. If we did that, then you plug it into the original function, and you'd have 6 squared minus 5 times 6 minus 6. And you're really going to see if that equals 0. So if we do this math quickly, 36 minus, well, these two turns out minus 36. Does that equal 0? Yes, sure does. So that one works. And likewise, we can check this one. Here's the check. That's what we're checking. Let me write that a little bit more neatly. So as I plug that in, negative 1 squared minus 5 times negative 1 minus 6, does that equal 0? This is going to be 1 minus plus 5 minus 6 equals 0. Does that work? 6 minus 6 equals 0 or 0 equals 0. So, yes, we check their answers. They both work. Therefore, they're both solutions for this quadratic equation. What about if we do another problem? If we solve this. If we want to use a zero product rule, again, the stipulation is that the whole thing has to equal 0 in the first place. What does that factor into? X and X. I always joke saying that's the hard part, being a little sarcastic. But now I need two numbers that multiply to 20 that add to negative 12. Four and 5, will that work? 2 and 6? Will that work? 2 and 6 don't multiply to 20. What about 10 and 2? What if I said minus 10 and minus 2? Would those two numbers work? In fact, they do. Negative 10 times negative 2 multiplies to positive 20. And the other one's negative 10x, negative 2x. Remember, we've been working on this mental math. They add up to negative 12x for the inside term. So again, we have something times something equals 0. Now we can use the zero product rule, which says that either, and I always like to put this either there, x minus 10 equals 0, or x minus 2 equals 0. Now, solving again. you get two solutions, I will be asking you again to check both those answers. For time's sake, I'll tell you they both work, but on a test or future homework, even your lab assignment today, I'm going to be asking you to check all your answers. So the check will be mandatory for every problem, because again, sometimes you have one solution, those solutions, or two solutions. Now, when you get to something like this, there's a problem in the sense that you cannot use the zero product rule unless it equals 0. Not a big deal. What you do is you just move it, or move the 3 over, so that then you do have a quadratic function that then equals 0 in an attempt to use this zero product rule again. It's pretty slick, pretty quick. So try it. Turn the video off, and when you come back, see if you get the same answer. Okay, if you're back, see, you put a 2x minus 1 in there, that might work. And x plus 3 might work, because the last two numbers again, -1 and 3, multiplied -3, and 2x times 3, which is 6x, minus 1x will give you your 5x. So good job if you got it. And again, if I come down here to solve each one independently, you get your two solutions. Now, what am I forgetting? What are we forgetting? Well, what's the other thing you're going to get points on? Probably checking your work. So make sure that when you're doing this, and again, for time's sake, I won't do the check now. They both work. But plug both of those numbers back into the original function. You'll be given points in your exam or your future quizzes and whatnot, to show that you're checking for all the solutions. What about something like this? I'll put a couple more up here for you to try. Again, turn the camera off and see what you come up with when you come back. I'll give it a shot. Okay, so again, the first rule with this is get everything to one side. So 5x squared, and now I'm going to not write everything down, but 2x comes over to this side. And one of these key features when this happens is you can pull something in common out. One of the first things we learned with factoring is always pull out a common term. So if I pull out an x, that leaves me with 5x plus 2, I believe. And this might not look the same, but it is still a product of two things. So either, oops, my apologies, we'll call this problem 3, this one problem 4. But either x has to equal 0, which is the first term, or 5x plus 2 has to equal 0, which pretty much means 5x equals -2, or x has to equal -2/5. The check, again, I'll leave to you. What about this problem? If I push 13x minus x squared equals 40, it's really your choice when you get to this point here, which way you move stuff. I like to keep the x positive, so I tend to move it to the other side always, whichever way would make it positive. And I apologize, some of the writing is kind of leaning. But again, the process is the same. You factor this in. First terms are x. Oh, let's guess 8 and 5. Let's see if that works. Minus 8 and minus 5, I think work. So if we completed these already, x has to equal 8. Or x minus 5 has to equal 0, which means x equals 5. Now, there's something else to consider as well. Give me 1 sec to erase the board here. And if you were ever given this, where you have a variable squared that equals some number, can you tell me what squared equals 9? Okay, I'm imagining that you say x has to equal 3, because 3 squared, 3 times 3 is 9. But doesn't, if I had x equals 3, that would be 3 times 3 equals 9. Okay, that works. But if x equaled negative 3, well, negative 3 times negative 3 would also equal 9. That would also make the statement true. So when you have a variable squared, especially when you're squaring both sides, your answer has to equal plus or minus the other side, because you have to consider both the positive and the negative possibilities. Really, that determines what's called the square root property. The square root property, write this down. It says that x squared, that if x squared equals c, then x equals plus or minus square root of c. Pretty much, I understand this a lot more easily than this. This is just a mathematical definition for it. A couple of examples, and then I'll let you guys work on your labs and give you your assignment. We're running long. Oh, I don't know what number we're on. Let's call this one number, let's see, we did 1, 2, 3, 4. Let's just call it letter A, problem A. If I give you this, and we'll go B down here. Okay, so if I use those two problems as examples, to do this, to square root both sides, you still need to divide by 5 on both sides, which gives you 6/5. And when you have that, when you square root both sides, you have to come up and be okay with the fact that that equals the square root of 6 over 5. We can talk about how to rationalize this later. But if I were to finish up square root of 6 over square root of 5, so you'd have square root of 30 over 5. Remember, rationalizing the denominator, something we already talked about as well. Now over here, if I square root both sides, well, anytime you have something squared, it comes out, it's itself, right? But because there's an x in here, again, we have to consider the positive or negative possibility. So when you square this side, it always has to equal plus or minus the other side. Solution, bring the 5 over. What you think? How about one more problem, a word problem from your notes? And if you're following along, these again are just part of your notes. You guys all have this stuff that I'm looking at. Let's do, let's see. Now if I have that, actually, why don't we give you a chance to do that? Turn the camera off, or excuse me, pause the video. I'll turn the camera off and turn it back on. When you come back from your video, I'll do it for you. Okay, now that you're back, it's equal to 0. We can use a zero product rule. So if you take out a common term, you get this. Divide both sides by 3. What's 0 divided by 3? 0. X squared bring the 11 over. And again, you have a variable squared. You have to consider the fact that it equals plus or minus the other side when you take the square root of it. So when that x comes out, it can equal plus or minus the square root of 11. Okay, one more problem, and then we'll set you on your lesson, doing your lab. You're looking at this from home. Look at the bottom example that says a circle has an area of 20 square centimeters. So you have a circle, and the area is equal to 20 centimeters squared. Find the radius of a circle rounded to the nearest tenth of a centimeter. So if you want to find the radius of the circle to the nearest tenth, you have to know something about area in general, right? What formula do you remember? For the area of a circle, well, circumference, if you're thinking about that, that's 2 pi r, right? But we don't want that one. We're talking about the area. And again, I would write the question up for you, but you should have it in your notes. But they want the radius of the circle when the area is 20. So if you remember, the area of a circle is pi r squared. We're given the fact that it's 20 as far as the area is concerned. So if I substitute that there, we'll end up with this. And like we've been talking before, a lot of the times you'll be given just about everything except for one variable, and that's usually what you have to solve for. If I divide both sides by pi, because I want to solve for the radius, I end up with 20 over pi, which equals r squared. And now I'm in a scenario where I have a variable squared again, so I square root both sides, but I have to acknowledge the fact that there might be a positive or negative answer. Now, when I do this, your real answer, your exact answer is the square root of 20 over pi, or r has to equal the negative square root of 20 over pi. You get it? Because that's what this plus or minus means. You have the positive or the negative. And here, to end the discussion, is really why I was telling you guys to always check your answers. So you either have the positive case or the negative case, but would it be possible to have a negative radius for this problem? It doesn't. So it's considered to be extraneous. So I just abbreviate that with EXT usually. But extraneous just means that you can't use it and that it doesn't work in the confines of your problem or the context of the problem. So you throw it out, and this is your solution. Okay? So hopefully we got through the first couple parts where we did the zero product rule and then also showed you how to handle some scenarios when you have an r squared or an x squared as far as using plus or minus that answer as well. And at this point, I'd like you to go ahead and do the rest of your lab, which is on the next page in your packet. Do the front page, A through F, and we'll go from there. Thanks for watching.